Hello everyone, in this video I will be telling you about the fourth part of unit 1 and this is the last part, and with this unit 1 would be completed. I would be starting with the K map. Before that we have already completed all this in the first part. Second part we have covered this, and third part we have covered all this. So the last part, that is minimizing using K map. K map, actually in this we make a table as it's shown in front of you. First of all, I read some theoretical part of it. That is, the arithmetic manipulation method is tedious and cumbersome. The K map method is faster and can be used to solve Boolean functions in of up to 5 variables. Okay, this is how it's shown. Up to 5 variables we can this. Consider the same expression from example 1 and minimize it with the help of K map. So this is, I just tell you first, it's AB, it's written. So the first value 0, 0, 1 is A, other is B. So the first value of every in the right hand side is A and the second value is B. So A is 0, 0, 1, 1 and B is 0, 1, 1, 0. Similarly, CD's first value is C is 0, 0, 1, 1 and D is 0, 1, 1, 0. What we do in K map is that whenever you find 4 ones together, as you can see in different colors, 1 is in 11, 11, the whole row is there, and in 0, 1 and 1, 1 and 1, 0, we have again all 4. So this is this we break it like this way, like this is, if you see the right hand side AB, this is 0, 1. So 0, 1, this 0, 0 is A dash B dash, this is A dash B, this is AB, this is A B dash. Similarly, C dash D dash, C dash D, CD, and this is considered C and D dash. So this is how we write it down, and the resultant would be list as above figure. The green spaces AB is there. AB, if you see the third row, which gives us AB, the red ones 4 squares gives AD, and the blues 4 square give AC, and when you minimize the Boolean it becomes AB, AC and AD. So this is how it's done. In the second example you can see it's more clearly. We always see 4 ones and we make a group of pair of K maps. So the following 4 variable Carnot map, Carnot. So the full form of K is Carnot maps illustrate the reductions of Boolean expressions too tedious for Boolean algebra. Reduction could be done with Boolean algebra. However, the Carnot map is faster and easier, especially if there are many logic reductions to be done. So this is we have again AB and CD is there. So you can see the 4 in the blue, it's written AB. Why AB? Because here the whole line is there AB, and this whole line is of CD. So this is how it's dedicated. We also take the 4 corners of it. If suppose 1 is on the 4 corners, when you close it, it becomes together, all together. So it can be written as B dash D dash. So this is how it's written. Another example, in this this 4 on the other side, this is also considered as 1. So this is how we have taken, like this is B, if you see, this is B, and this is C dash D dash, and this is B C D dash, and this is A B dash D, and similarly all the others B dash D. Like this is B dash, and the blue one, the red one, and the blue one is D dash. So next topic is error detection and correcting codes. So error detection and correcting code plays an important role in the transmission of data from one source to another. The noise also gets added into the data when it transmits from one system to another, which causes errors in the received binary data at other systems. The bits of the data may change either 0 to 1 or 1 to 0 during transmissions. So this is how the error detection and correction techniques. We have 4 things. We have Parity code, we have checksum, we have cyclic redundancy check, that is CRC, and the last we have Hamming code. So I will be explaining all. First of all, the parity code. Parity is, in parity code we add one parity bit either to the right of the LHS, that is left side bit, or left to the MSB, that is most significant bit, to the original bit stream. On the basis of type of parity being chosen, two types of parity codes are possible, that is even parity code and odd parity code. Then we come Hamming code. Hamming code is an example of block code. The two simultaneous bits errors are detected and single bit errors are corrected by this code. In the Hamming code, mechanism, the sender endures the message by adding the unnecessary bits in the data. These bits are added to the specific positions in the message because they are the extra bits for correction. So Hamming code, they are the extra bits for correction. Hamming and cyclic code. Cyclic code is known as to be a subclass of linear block codes where cyclic shift in the bit of the code word results in another code word. It is quite important as it offers easy implementation and thus finds applications in various systems. Cyclic codes are widely used in satellite communication as the information sent digitally is encoded and decoded using cyclic codes. These are error detection codes where the actual information is sent over the channel by combining with the parity bit. So this is used in satellite communication, the cyclic codes. Coming to the property 1 of cyclic code, that is property of linearity. According to this property, a linear combination of two codes words must be another code word, that is CI plus CJ equals to CP, where CP must always be code word. Property of cyclic shifting. According to this property, after a right or left shift in the bits of code words, the resultant code generated must be another code word. Suppose C is a code word given as C equals to C1, C2, C3 till Cn minus 1. So this is a cyclic shifting. So this is how it's explained in this diagram. Then after cyclic shift, there is C equals to C1. There is C1 is shifted here and Cn minus 1 has come in front. Similarly, Cn minus 1 has moved forward and Cn minus 2 has come here. This is the cyclic shift. Hence, we have prepared this right cyclic shift that has produced these code words. Now comes the next topic, that is Hamming code. Hamming code is a block code that is capable of detecting up to two simultaneous bit errors and corresponding single bit errors. It was developed by R.W. Hamming for error correction. In this coding methods, the source encoding the message by inserting redundant bits within the message. These redundant bits are extra bits that are generated and inserted at specific positions in the message itself to ensure error detections and corrections. When the destination receives this message, it performs recalculations to detect error and find the bit position that has errors. So this is how it's done, encoding a message by Hamming code. The procedure used by the sender to encode the message encompass the following steps. Step 1 is for calculation of the number of redundant bits. Then redundant means duplicate bits. Then step 2, positioning the redundant bits. Then they position those duplicate bits and then they calculate the values of each redundant bit. So with this, I say thank you, and this is my email ID for all the viewers who are seeing. You can mail me if you have any problem, or you may write in the comment section as well. Thank you and have a nice day. Thank you.